let us look at the problem statement of Leetcode, finding all the duplicates in an array. You would be given an array like 1, 2, 3, 4, 5. These are the array elements. And each element can either appear like once or it can appear twice. So here each element is appearing only once, but you can also have something like 1, 2, 2, 3, 4. In that case, you have to output this 2 because it has appeared twice. You can also have something like 1, 2, 2, 3, 3. In that case, you have to give output as 3 and 2, right? So now it is clear what to do. One more information that you need to check is the array has like every element is within the range of 1 to n. And this is a very important statement which we will use in solving the time, in solving the problem in order of n time and order of 1 space. But let's look at how to solve it using a brute force method. Before that, these are some kind of examples. So here nums is equal to this array. Here you can see 2 is repeating twice, so it is in the output. 3 is also repeating twice, so it is in the output. Same here, 1 is repeating twice, and here nobody is repeating twice, so an empty output. There are two brute force approaches to this problem. First is you can use sorting, and the second one is using hashing. Okay, I will just quickly just go through it. So it is very clear that if you just sort all the array, you know that every element is in between the range 1 to n. So if you sort the array like 3, 4, 5, 1, 2, 2, right? And some 3, you will get 1, 2, 2, 3, 3, and 4, 5, right? Then you can keep a track of previous element. You are at over here. If the previous element matches, then it is here it is not matching. You will go over here, you will see it is matching, so 2 is in the answer. Then when you reach over here, you will see that the previous element is matching, this will be the answer. So that is how you will go. What is the time over here? The time will be order of n log n, firstly to sort, right? And then to conduct this, that will be plus n. So this iteration. Next is what is the space for required for this? So it is kind of order of n. If you use merge sort and even if you use something like quick sort will also take order of n worst case. Order of n log n space it takes in the average case, but order of n worst case because you can have some kind of unbalanced partition, and that is the whole stack space that I'm talking about. That is sorting. Okay. Let me show you. This is the code. You can see we are sorting the nums array, then we are taking previous as 0, and if my x, that is an element of the nums, is matching the previous, I will be pushing it into the answer, and then my current element becomes my previous element. This will take order of n log n time and order of n space. Second approach is using hashing. Again, we will just keep a track of the elements. So 4, what is its count? Right now it is count is 0. Again 3, the count is 1. Right, 2 count is 1, and so on. So when you reach over here, this 2 you will check in your map if it is like C++ or hash map if it is Java. You will see that there is some count which is already there. So you will be uh, adding that element to the answer, right? So here also 3 is already there, so you will add it to the answer. And this will take order of n space and order of n time. But this is again if there are no collisions. If you have such a hash functions which violates the collisions, yeah, you can it can also go to order of n square worst case, right? The code for this would be this. So I have defined an unordered map in C++ where it first is the element and next is its frequency. And if I check, if I see that it is already there, if the map of x, that means the frequency of this element is already 1, uh, that means this is the next element that I'm getting, then it is a duplicate element. I will just add it to the answer. Else, I will I will increase the frequency. This will take, as I said, order of n time, but again, sometimes it can also take order of n into order of n, where worst case, so it is order of n square, and it will also take order of n space. Let's discuss the optimal method to solve this problem. The main point over here is the range, which is given 1 to n. So in such type of problems, you can see that the indices which are there or the elements which are there, they also act as the indices, correct? So I have a 4. This 4 actually corresponds to this index 3. This 3 will actually correspond to this 2, right? 2 will actually correspond to 1. So every element x will actually correspond to an index x minus 1. Okay, we will use this fact. Now, what is the logic or approach behind this? Let's say I take this 4 and I will try to make it a home in this address 3 over here. Okay, then for 3, I will try to make a home at this address 2. For 2, I will try to make a home at this address. For 7, I will try to make a home at the address 6. For 8, I will try to make a home at the address 7, right? For again 2, I will try to make a home at address 1. But you see that someone has already made a home over here. So, and who made it? This is the 2 which actually made a home at address 1. But now we have encountered one more 2 who wants to make home at the same place. So this is a collision. So this is where we can say that it is a duplicate element. That is the basic logic to it. But you may ask that, okay, this all is fine, but you still have to store this. This is kind of like a visited array, right? Visited means I am saying that I encountered 2 and I'm saying I visited this particular index, right? Or whenever I'm encountering an x element, I'm making a home at the index x minus 1. So I have to store it somewhere, right? So you can use that nums array itself, which is already given. How can we do that? Is let us take this example again. 4 3 2 7 8 2 3 1 0 1 2 3 4 5 6 7. These are the indices. So whenever I say 4, it wants to make a home at the index 3. Why don't we just mark this element as negative? Mark this element as negative. That's it. Don't touch the value. Don't touch the value, but just mark this element as negative. Okay. For example, let's say when this 2 tries to make a home, it will just mark this. So this is its address, right? Minus 1 is its address. It will just mark the element as minus. We will not touch this value. And when the second 2 also tries to check, it will see that, oh, okay, the values, the range is supposed to be 1 to n, but then I see that a value is negative, right? A value is negative at some particular index. That just means that someone has made a home over there or someone encountered this element. So that is where we will say that this element over here is a duplicate element, right? So that is how we will proceed. Let's just write down the pseudocode for this. So it's just one iteration. For I is equal to 0 to n minus 1, we will just iterate through the whole array. And we will first make the address, home address, right? What is the home address of this element, That will be nums of I minus 1, right? And that the address for 4 will be 3, like that. Okay. But make sure that you take the absolute of this because whenever you will try to make a home for 7, but 4 has modified it to be minus 7, right? So this will be like minus 7 minus 1, and you will try to access a home which is not there, a home for which index is not there, right? So that is totally wrong. So that is the reason we will take an absolute. Okay. So once you get the home address, you will check if someone has made a home over there or not, right? If someone has made a home. So if nums of home, that is your address, is negative. If it is negative, that means someone else had already made a home. Then I will just push back. Okay, add to my answer list. I will just add this nums of 5. Okay, so I will just add it to my answer. Else, nobody has actually made a home over there, so I will just make it. How I will do that? Whatever I have at that point, it is 7 right now. So I will make it negative. So that will be minus nums of home. So that's it. This is the small code. Let's just see the code for this thing. The code is the same. I am going to iterate through I is equal to 0 to n minus 1. This is my home address, right, which is absolute of nums minus 1. And if you see that someone has claimed that home, that means you have a duplicate, that means it is negative, and I will just push back my nums of 5. Make sure to put absolute also because minus 7, you don't want to push minus 7. You don't want to push any negative number inside your answer. Else you will claim that home if nobody has done. Okay, so nums of home is equal to minus nums of home. So that is the whole code for it. So this approach is order of n time because you can see this loop, right? And order of one space. We are only modifying the nums array which is there. We are not doing anything else, right? So order of one space. There is also one more approach you can think of is that using such a kind of thing. This is also order of n space and sorry, order of n time and order of one space. Here also we'll modify the nums array. How we can go is I will like choose one and one element. So let me take the first element and I have taken it to process. So I will just mark it as minus 1. Now, my aim is to actually put this element at its right place, right? So what is the index over here? You can see that its correct address is 3, right? But I have to store this 7 somewhere. So what I will do is I will store it in the temp and I will store it over here. Okay, it's 4 over there. Okay, now I will go ahead. No need to go ahead. Again, what we can do is we can again check. We can again we will have a new element in the temp. So again, our aim is to put the whatever element is there in the temp to its right position. Okay. So what is the right position of 7? The right position of 7 is 6. So let me put it over here and let me take that element over here. Again, 3, right? What is the correct element? Correct position of it? It is 2. So let me put 2 over here and let me just swap these two elements. Okay. Again, for 2, you can see this will happen. Now, if you see, I have 3, correct? I have 3 and its position is 2. But there is already an element which is satisfying. There is already an element which is satisfying this condition, right? So that means the 3 that I have is actually duplicate element. So I will just add it to the answer. Answer is 3. Okay. And I will increment my I. So my I was over here. So right now, because this is already done, now I don't have any other element to put forward, right? So I will increment my I and say, then I will check, okay, this is already at its correct element, right? This 2 is already at its correct element. Again, increment I. Again, I see this 3 is already at its correct element. Again, increment I. Now I see again this 4 is already at its correct element. Again, increment I. Now this 8 is not at its correct element. So I can try to put it in its correct location. So before that, I would have to add it to some temp variable. What is its correct position is 7, right? So we can just swap these two. Okay, and before that, you can also mark this as minus 1, okay? Because I say that I am now processing that particular element. So that is the reason. Again, what is the correct position of, oh, sorry. Here, we do have the correct position of 8 to be 7, right? So it would go over here and 1 will come over here. What is the correct position of 1? It will go over here and we will have minus 1. So minus 1 which is that is the reason why I took -1, right? Over here, just to have a swap. So we don't have any element right now. Okay, this -1 indicates that we don't have any element. Again, increment I. Now you see that this 2 is not at its correct position. So again, take it, mark it as -1, and take it. Okay. Now again, we will take 2. And what is its position? It is 1. But you see, at the 1 index, but 1, 2 is already there. So we will add it to the answer because this is a duplicate element. Now again, we don't have any element, right? So again, I will increment I. I will see that, okay, 6, this 7 is also at its correct position. Again, I will increment I. I will see that, okay, 8 is also at its correct position. Okay. Again, I will increment I and I will reach at a 9 index, right? So when I reach out of bound, I will stop. And that is where I will return this whole answer. Okay. So this is one of the approaches that came to my mind when I was solving it. So that is the reason I'm telling you. Let us look at its code right now. This is the code. I will not be explaining like each and every line of this. So you saw that we saw brute force 1, brute force 2 method, optimal 1 method, and now we are trying to do an optimal 2. Okay. So here you can just check it yourself. I will just briefly explaining what is going on. It is according to the logic that we have discussed, right? So we will start with our, we have this Rn and we will start with nums with the first element, okay? And I will start my traveling from I is equal to 0. Now, while true, what happens is I will try to take first element, which is, which is not at its correct position. So I is equal to nums I minus 1 just means that that index, that element is at its correct position. If it is not, then I will still be going to I plus plus. And I will stop doing all of this if my I goes out of the bound, right? Out of the bound. Yet I will, if that is not the case, I will be having I within the bound, and I will take that I and I will process it, right? So I will put a -1 at that place just to avoid some kind of duplicacy. And then what I will do is I will check if nums of temp I minus 1 is equal to 10. That just means that what is my goal right now? Whatever is there in my temp array, or sorry, in my temp variable, I have to put it into its correct position, right? So what is its correct position? The index is temp minus 1. If temp is already at its correct location, that means temp is equal to temp nums of temp I minus 1. Okay, so if some other element is already there at this position, I will just put that element into the array and I will just do a I plus plus and break out of this. Okay, else nobody is there in that location. So what I will do is there are only two possibilities now. So either there is someone else. So if there is someone else at that location, I will just swap the elements. Else it will be -1. If it is -1, I don't have any other element for processing. So that is the reason why I will do a I plus plus. And again, I will take the element of temp to be nums of temp -1. That means I will put temp at its correct position and I will break it up, right? So this whole process, as I said, it will take order of n time and order of 1 space. So that's it for the optimal 2.